Hello and welcome to Algebra 2, Chapter 1.6, and today we're going to discuss solving linear inequalities. So when we're done with this lesson, you should be able to solve simple linear inequalities and also compound inequalities, and if you have forgotten what those are, we will remind you. So a linear inequality is just an inequality with a variable to the first power. So any linear equation, linear inequality, you're always going to have a variable to the first power, so no squareds, cubes, no variables on the bottom. So we're looking for a solution that makes the inequality true. So keeping in mind that an inequality gives you a range of answers, so let's say you end up with x is greater than 3, there's a whole range of solutions that would be true. 4, 5, 6, 7, and any decimals in between. So keep that in mind that for inequalities, there's this range of answers. We need to talk about what transformations you can do to an inequality and keep it as a true statement. So similar to equations, you can add and subtract to both sides, no problem. So for example, if you have 4 is less than 6, if I add 3 to both sides, 7 is less than 9, so that stays true. So the same thing if I subtract. If you multiply each side by the same positive number, you're also fine. So if we multiply each side by 2 and we get 14 is less than 18, that stays true. The deal though is if you go to multiply or divide each side by a negative number, so this last bullet here, if you multiply or divide by a negative number, so let's look here real quick. Let's divide each side by negative 2. You're going to get negative 7 is less than negative 9. That's not true. Okay, if you think of a number line, negative 9 is to the left, negative 7 is to the right. So if you divide or multiply by a negative number, you must flip your inequality or reverse the inequality. That's the only change in steps from solving an inequality to solving an equation. So one more thing to remember there, that's it. So because an inequality gives you a range of answers, we're going to be interested in graphing our answers. When you draw a number line, you're always going to put arrows on both ends. And I don't necessarily care how you put the numbers on the number line, except if you just graph one number. So if I say x is greater than 3, and I say, well, there's 3, I'm done. That doesn't tell me anything about 3. So graph should be a visual. So I want at least one number on either side of the number you're graphing. So we're going to use open circles if it's just less than or greater than, closed circle if it has an equal to part. So this one would be an open circle. So I'm going to put an open circle on 3, and then you draw an arrow in the direction that corresponds with the inequality. X is greater than 3, so we're going to draw our arrow to the right to reflect greater than. Okay, so then everything that it's graphing there is a solution to that inequality. So you're graphing that entire solution. Alright, so let's try this out. We're going to solve and graph. So just like an equation, I'm going to get y by itself. We're going to start out by adding 9 to both sides. We're going to get 11y is greater than 22. And our next step should be divide by 11. And as long as we don't divide by negative, we're going to keep our inequality. So y is greater than 2 is my answer. And then we're going to graph it. So I'm going to put at least one number on either side of 2. Since there's no equal to part, it's going to be an open circle on 2 and an arrow greater than. So we're going to go to the right. So there we have solved and graphed that inequality. A word problem to look at. To receive an A, Sachi must have at least a 90 average on her last 3 exams. Her average is x plus 174 over 3, where S is her final score, so that's her 3rd exam. Describe the final scores that will give Sachi an A. And so in fact, let's make that an S there. Alright, S plus 174 divided by 3. So this average, so the 174 must be the previous 2 exams. This average must be greater than or equal to 90 for her to have at least a 90. We're going to solve this. So if you solve something like this with a fraction, the first thing you want to look at is multiplying by that denominator to cancel the denominator. So s plus 174 is greater than or equal to 270. And we're going to subtract 174 from both sides, which leaves us with s is greater than or equal to, and do take note that we're not switching the inequality, 96. So she must get a 96 or greater on her final exam to receive an A. We're going to end by talking about compound inequalities. So the examples I just did were simple inequalities, they were just one. A compound inequality is two inequalities joined by the word and or. If you use the word and, it means they're both true. So if I say I'm taking Algebra 2 and chemistry, then they're both true. If you say or, one of them has to be true, or they both could be true. So if I said I was taking Algebra 2 or chemistry, as long as I'm enrolled in one of those courses, that statement is true. So we're going to pull some inequalities together with those two words. So this is what an and inequality looks like. Notice there's no word and in it. Okay, there can be the word and, but you really almost kind of prefer there not be the word and. They're a little easier to work with. If I'm going to solve this, I'm going to look at this as having three parts. I have a left-hand side, a middle, and a right-hand side. And whatever you do to one point or one part, you do to all of them. So if I want t by itself, I'm going to subtract 4 from all three parts. Negative 13 less than t less than 6. Done. So instead of having the word and you have two separate inequalities, you got to solve them both. This is just one solved, got my answer. I'm going to graph it. Now we're going to need to graph both. I'm going to have to make my number line bigger here. It's hard to write small numbers. Let's see. Bear with me for 1 second. You don't have to count by ones. You could count by twos. Especially since I'm running out of room here. Ah! Oh, hold on. We should try again. It happens, right? This is why you do work in pencil. Okay. How about negative 14, negative 12, negative 10, 2, 0, 2. There we go. All right. So looking at the left-hand side first, that reads t is greater than negative 13. So to graph t is greater than negative 13, we put an open circle on negative 13. If it happens to be where you don't have a tick mark, then we're going to write that in. And so greater than is going to go to the right. So it's going to go to the right forever. But here's the deal, is that this is an and, so I need it to be in both. The other side says t is less than 6. That's an open circle on 6. Less than is an arrow going to the left. Those arrows are going to run into each other, and that's what your graph looks like. Okay? You want that overlap. Technically, the arrow is going all the way to the left and all the way to the right. But if I want it to be in both of those, I'm only going to do that overlap in the middle, so you do not need those arrows going both ways. Okay, we're going to look at an or statement. Now, ors will always say the word or in the middle. And so you have two inequalities, and we're going to solve them both. And we're going to keep that word or in the middle. I'll rewrite it on the answer. So just solving them like a simple linear inequality, we've got less than negative 6. Okay, I'm not dividing by negative, so I'm going to keep my inequality and the word or. So we get 3x is greater than 21. X is greater than 7. That's a greater than. All right, so there is my answer. to graph that, should have picked some examples that the numbers were closer together. There we go, now I made it way too long. Alright, x is less than negative 6. Well, that looks like this. That's less than negative 6. Greater than 7. I'm going to put 7 over there. Greater than 7 looks like that. That is typically what an OR looks like. They go opposite ways. So your answer could be over here in this region, or it could be over here in that region. Okay, that's what I have for you for 1-6. Let me know if you have any questions. We'll finish your notes in class next time. Have a great day.